What's up, what's up, what's up, everybody? Welcome back. Today we are working on my Google Maps replacement, and today's topic is continuing on with trying to optimize our bus planning algorithm. So for context, sometimes I go outside and I have to leave my house to get there. And, maybe I'm trying to go to somewhere that I'm not really too familiar with, or I'm going somewhere that's like pretty across town and I don't know like which set of buses is like the best set to take today, right? And so I go to Google Maps and I say, hey, how do I get to the bar? And it says, take 3 buses and transfer 2 times, because 3 buses, you need to take 2 transfers. And, it'll say things like, take this bus to instead of walking 5 blocks. And I'm like, dude, like, first of all, I know that I can take the express bus and walk 10 more blocks and I'll get there faster and more consistently, right? And if I'm like, I'm like not sure, I'm not like gonna be like get to the bar at exactly 7 o'clock, right? I'm gonna get there like maybe like 7:05 or maybe 6:55, I don't know. And if I miss when Google Maps tells me to leave, then I just end up like half an hour later because like the bus comes once every half hour and I miss the first bus. And it's like, no, this isn't what I want, Google. What I want is for you to tell me what is like the most consistent and fast way to get there, not the version that takes least walking and is fastest if you leave at this precise time, right? And so I kind of figure that, you add that up with a bunch of other stuff, and I come to the conclusion that I just want to make my own path planner that's like really tunable, right? And so that's what we've been working on. This is an example path, right? So I can, I go over here and I say start here and I say end here. And he like picks a path to walk on. He's doing something stupid here where he's saying like walk down the middle of the street. So I can say like, okay, whoa. Dude, I'm on my feet right now. And so like, let's look at like, color our sidewalks blue and we'll say, hey, look, the sidewalk is much preferable to the street. And I like reset the path, and now he says, oh, you like sidewalks, I see. Let's put you on the sidewalk, right? And so we have like, we have like the idea of like momentum. And we've recently started on adding in bus support. So actually I want to take this sidewalk thing off because like it's the same color as the transit. And if I go in here and fuck. Sorry, wrong window. Wait. Chill. Give it 1 second. So I said it's a work in progress. But we've been working on this bus integration. And let's try this again. I think that it might have to do with like the order that I punch this stuff in. So let's try this. If this crashes again, then we're in trouble. Okay, so here, I'm gonna kind of like step it a little bit manually because there's some bug somewhere that I haven't investigated yet. But here, if I tell it to take the bus, we can see like, okay, so he did choose to like walk over to this bus stop and take the bus over here. And if we look at like what nodes it looked at along the way, we can see that it is kind of like jumping through the bus system if possible. And what we've been working on for the past couple days is looking at how this is absolutely unbelievably slow. And so we were looking at this yesterday, trying to say like, what if we subsampled the world? I guess I should explain why. The reason it's so slow is because in A star, which is like the algorithm that we're using to do path planning, the reason that we are not seeing like every single node between us and our destination lit up like a fucking fairy tree or whatever, like a Christmas tree, I should say. Fairy tree, I don't know where that came from, is because it is intelligently picking which node is like the most likely next candidate, right? So in A star, if you are trying to get from here to here, and you have like, some nodes over here, and you have some nodes over here, it kind of like starts here and it goes like, if I straight line distance from here to here, or here to here, or here to here, those numbers are lower than if I straight line distance from here to here, or here to here, right? And so he's going to look at neighbors that look closer to the end destination, right? So we go here, and then we'd probably go like here, and then here, or something, right? And like he uses that as like a heuristic while combining that in some way with the actual distance traveled, right? So when you add in buses, all of a sudden this concept of straight line distance kind of goes out the window, right? Because if I have like a bus system that goes, like this, and I'm trying to get from here to here, and maybe we have like another bus route down here that goes like this, it looks to us like we should go this way, right? But we know, looking at this as humans, that we should go down. Because then we can get on this bus, we can take the bus around here. Maybe that bus is faster. Maybe this bus isn't faster than walking, but maybe this bus is faster than walking, right? And so what we do with our first attempt here was just like make up some shit. Who knows what we actually should do, right? But what we decided was we will walk towards the closest bus stop that is on a bus route that we have not tried yet, and the final destination. So what we do here is we go like, if there's like this bus stop, this bus stop, this bus stop, this bus stop, this bus stop or something, we'll try to walk to this. Then when we hit this, we go, okay, we won't try to get to here, we won't try to get to here, we won't try to get to here, we won't try to get to here. But we will still try to get to this one, this one, this one, this one, this one, right? And then we keep going down, we get to this one, we go, okay, we've hit all these. Then we're only trying to get to the final destination, but now we have all of these connections and we know that they're very fast and we know that they're next to us. So the A-star algorithm will choose to take those steps next. Wonderful, right? But the problem with this is there's 5,000 bus stops, and for us to say which one is closest, every single node we inspect, we check our distance at every single one of the 5,000 bus stops. It's like, what are we doing? Obviously that's slow, right? And so it's so slow that when I try to run this algorithm, our application crashes because we're not like servicing the window fast enough. I don't really know why, but that's my guess. And so the reason that we have this like blue overlay is because we were investigating yesterday the idea of basically trying to pre-calculate the distances at like some interval, right? So we go like this one points here, this one points here, this one points here, and then we were like, okay, so if we're in between, we will just like subsample, we will like basically interpolate these two vectors, and we'll kind of like assume that it's like kind of like this, right? And it turns out that that's a bad strategy. It's just like a really bad strategy. If we kind of like turn on, like get this visualization in like a kind of form where it's like visible, we see that we end up with like, sections that are like hot, that are like not close to bus stops at all, and also like sections that are not like that are close to bus stops and are not hot. And I believe what's happening here is that if you have, this bus stop, you have a bus stop like here, and you sampled here and here, if you look here and you interpolate these two vectors, you get 0. And that 0 seems very close, but it's not. And so this strategy of just like pre-calculating each thing and pointing in the right direction and then averaging them up, bad idea. Bad idea. I'll take credit for that. I'll take credit. But a better idea might be if instead of doing this exactly, we could still try the same approach where we subsample, except instead of pointing the closest bus stop, we will just point in its direction. And what I think that if we are kind of like, say we have like a bus stop here, this guy kind of points like this guy kind of points like this guy kind of points like this, and I think that what we can do is, if instead of doing whatever the fuck I said before and like averaging these two vectors, I think if we kind of do something and say like, okay, so I'm here, and if I project this distance, like from this point to me onto this direction, we can make some sort of guess about how close I am. And maybe we will interpolate those projections with like the adjacent nodes. So if we have like 4 of these arrows kind of pointing around like this, and we're like in this area, we can kind of like use these 4 arrows and say like, okay, so I'm like closest to this one, so I'll use this one the most, and then I'll use this one a little less, and this one a little less, and this one a little less, but we'll still kind of like see if like I'm in the right direction. I kind of want to see how that works. I think that will make a more reasonable answer than what we have here, but it might not still be good. It might still not be good enough. We'll see. I've come across this concept. I think I've seen it called vector fields in like H.264 encoding. I think is where I first came across this. Maybe not. I remember I've seen pictures of like, yeah, stuff like this, where you kind of have like at each point, so for an H.264 frame, right, you have like, it will encode frames as like deltas between things. And so like I've seen this idea of like each pixel has an arrow representing like where it came from in the last frame. And so then you can kind of like go backwards. This is where like I've thought of this from. I'm sure I've seen it somewhere else as well, maybe in some sort of like neural network stuff. I don't know. But anyways, it seems like an idea that would work, maybe. And so I think we'll try it. So the plan of action is, in order, the data format we were using yesterday does not quite lend itself well to this. Yesterday we were rendering this in OpenGL by like basically providing vertexes as well as their vectors, right? And then OpenGL will kind of like automatically interpolate these things for you. So if you are, you're drawing a triangle, here, and you have like these arrows like this or something, it will be like, okay, so on this point, and this point, I'll average those out when I get to this point. This doesn't work for us anymore. So I think that the approach I want to take here is I want to draw one big rectangle in OpenGL that covers the whole screen. And I want to basically attach our sampled directions as like a texture. So we'll have like kind of like an image that kind of has like the position in the red and green channels and the direction in the blue and alpha channels. And so each pixel here will represent one sample that we took in our like big image. And then as we run our OpenGL shader, we'll run for each like screen pixel in here, and we can do like manual interpolation of this stuff like in the shader. Right, so we can be like, oh, so we're here in the image, which means that we should look at this pixel, and we can pull out the like position that we're relative to as well as his direction. We can do some sort of like vector field manipulation, and then hopefully we'll have like some idea. We'll have some idea of how it looks. But before we do that, I think I want to like render the current data. Render the current data with this data format. Then we can adjust the data to be what like is actually saying. Then we can render this thing in like our OpenGL shaders to make sure that we believe that we're going to get some sort of reasonable answer. Then we'll port to the CPU and integrate with Pathfinder. That's the plan for today. Could you not just limit the stops in a radius around you before checking the distance? Yes, but I think that's worse. I think that is worse because like here's the thing. If you're like over here and you have like a bus stop here and your end location here, you still have to know like if you're going like, or even worse, right? You're here, you have a bus stop way over here and your end location way over here. You still need to determine if you want to walk this way or this way, right? So you do need like, you need something, right? Whether or not that's like, maybe we just don't care about far buses, maybe that's like a real answer. I don't know. But I think that we can have it all. We could limit ourselves like that, right? By like limiting the amount of calculations that way. But why do that if we can just almost for free get like an instant lookup that's like accurate and correct and globally like consistent, right? It's just, why not do this? Plus, this is what I feel like doing right now. And we optimize on this channel for doing what we feel like more than doing what is correct or reasonable or the most efficient. So let's jump in. So step one is to look at our heuristic renderer and basically try to adjust the data format here. So we have our like closest stop fragment shader. This guy is going to take in a uniform, a sampler 2D, I think. We have a textures renderer somewhere. We have our like, in order to render our image, our satellite data, we do this somewhere already. So we can look at like image tile, image fragment. Right, so it's a sampler texture. And then our vertex shader for that guy. What is it? Tile GLSL. Somewhere we have some code somewhere to generate a quad and render it. But I don't know why. We must use the same vertex shader as everything else, which is fair because we kind of like we take our input positions and we like basically modify them according to where the camera is and turn them into screen space according to these rules. So I guess it is fair to just reuse this because we'll kind of set our corner coordinates of our shader to be relative to those points on the screen. Yeah, I think that's fair. Oh, but do we need to propagate info here? No, if we bind the sampled points as an image texture, then we don't have to propagate any extra info from vertex shader. So our heuristic renderer can actually use the exact same vertex shader as our map line renderer, and it will do the exact same thing. I think that's actually fine. Yeah, that seems reasonable. So our input, we have no input here anymore. I guess no, we do. We need to know where in the image we are. How do we do that in the image fragment shader? Oh, they do have an in, UB out. So what do we do on our like texture renderer? I'm confused actually. Here he uses, oh, rect GLSL. Ah, okay, this makes more sense. This makes more sense. And he just does everything in screen space, which also isn't really what we want. But we do probably want to keep this like rectangle. We can keep like the point rendering directly inside here. So maybe we'll start from here. And we'll call this, what was it? Closest stop vertex shader. So I still think we want to render here according to the full image. I guess maybe not, because we need to render the points in like meter space. So never mind. We will keep it like this. We are not going to output closest stop, but we are going to propagate our like vertex position to the fragment shader. So here we must do something like pause. reasonable. We'll call this like frag in. Hero Dev, thanks for the raid. What's up, you guys? I forgot to write down the time here, but it was sometime before 60 minutes. And now he thinks that we're in a HTML tag, which is kind of funny. So we'll just kind of throw that thing in there. Okay, so for raiders coming in, I'm gonna try to give you the quick version of this. Quick version is we have a map. We're trying to work on our path planner. Path planner needs to find where the closest bus stop is. We were visualizing that. I can't show you the visualization right now because it's broken. I'm sorry. But we were basically trying to subsample in the world, you know, where is our closest bus stop? So we, you know, here you have like bus. You have, I'm going from here to here. Give me closest bus stop. And if I hit bus stop already, don't try to go there anymore. We've already checked it. And so we are working on basically trying to find an efficient way of doing this lookup, subsample the whole world, and make like a field of arrows that kind of point towards the closest bus stop. So like if we're going here, it's like close, and we can basically just like interpolate, looking at each point, which way do we go? Where does the arrow point? We'll go that way, right? We are binding all of these samples to a texture that we can render in OpenGL, and that's where we're at right now. Apologies for the shitty explanation, but it's just because we just started, and that means I just gave an explanation to everyone else, and I don't want to like waste too much time repeating that. So I apologize. Okay, so as we go to the fragment shader, want to tell it which points to sample from. So I think that we actually just propagate the input position. I think we just say frag in is equal to vertex pause. Because this position is going to be in like meter space in our map. This conversion goes into screen space. And our texture is going to know, we're going to know how wide our samples are. And so we can use that meter space position to decide which pixel to sample from in our texture. I think that makes sense. So we can go fragment stop here. He's going to take in frag in. And he has a uniform texture to sample from. And before we sample from that texture, let's just try actually doing something like trying to render a like RGB thing that indicates where we are in the map so that we can make sure that like we're rendering everything reasonably. So I think we'll take in like the width and the height of the like world that we're working with, and we'll just say that our frag in x over width is our r value, and our y over the height will be our g value. And we should see this like fun little red, yellow, green rectangle thing. That's what I'm hoping to see here. But more likely is that this won't compile or won't run. Okay, so before we do any of this, we have to go back into our heuristic renderer, and we need to adjust the type of data he's binding. So before, we were using like an element buffer and a vertex buffer with a bunch of data related to our closest stop lookup thing, and we don't really need to do that anymore. We do still want a vertex buffer object, but this vertex buffer is going to be constant in what it contains. It's going to just have 4 points. Based off of, I guess, the like width, the meter metadata. So we'll just call this like metadata is this. And we're just going to set our points according to that input data. So we're going to do something like buff const points is going to be like 4 floats, 8 floats, 2 dimensions. That makes sense. And this is going to be like, I guess we can do this as a slice. And here we're going to say what? We're going to have like metadata width. We're going to start at like 0, 0. Okay, that seems reasonable. Then we're going to go to, if we're drawing a triangle strip, we want to make sure that we start in the top corner and in the bottom right, or top left to bottom right is what we want to do here. So the next one is going to be width 0. Then the next one is going to be 0 height. And then the last one will be both. All right. I don't know what this thing is confused about. I think I forgot to put a dot here. Apologies for ignoring a couple questions in chat. I am just trying to focus, so you're free to post what you want, but I'm also free to ignore what I want because this is my stream. Okay. So now we have to like upload these points to the GPU. And we upload points pointer, points length. Each point is 4 byte floats, so that's why it looks like this. Is getting time since X data nanoseconds and adding random N64 number to it good enough to rule out any collisions? I don't know, like, in what context. Are you talking about in the map or just, like, generally? I wouldn't use time if you're trying to avoid collisions and things like at all. I think time is like a bad metric here because you don't really know that time is going to go forwards. Sometimes time goes backwards. Like daylight savings. Then what? Then you're fucked. Okay. So we are still saying that we have some floating point inputs. There are 2 of them. They are not normalized, except they are 8 bytes apart instead of 16 bytes apart now. And then I think we are chilling. This feed function, I think we're just going to disable this for now. He doesn't need to do jack shit. Num points also goes away here. Here, I'm sure we're going to need to do something when we try to update our data later. I just don't know what it is right now, so I'm just going to be like, get this shit out of here. Okay. Then instead of binding an element buffer and drawing elements, we're going to do GUI GL draw arrays. So we're trying to draw 2 triangles in a strip. A triangle strip, I say. And this is going to have first 0 and last 4. We're drawing 4 elements. 4 points, because we're drawing one big ass rectangle. That seems right to me. Disk scale's gone now, I think. But it might come back. And let's just build and run that and just see what happens. So zig build, optimize, release, save, DLTO equals false, bin, and map on our output. Fuck! It's because I wrote equals here instead of dash. He doesn't compile. Of course he doesn't. Because in app.zig, we need to pass in that meter metadata. Boom. Easy fix. Expected type this, found that. Because I have to write const somewhere that I didn't, I think. Here I want to write the word const. So that he knows that those are not to be messed with. Do not touch those floats, please, sir. All right, so time changes twice a year. I mean, honestly, it's just more that like you're using something as like an approximation of randomness that's not. Right? I just think it's better to like just generate a string of random numbers that has a low enough chance of collision that you don't have to worry about it. Okay. So how do we test this? We turn on transit, we turn on path planning, we hit path end here, and we should see something happen here. I don't know what. We see... I was hoping to see one big-ass quad drawn over the whole screen. We're not seeing that, and it's actually really hard to know why. Because I don't really understand why, but it feels like our OpenGL debug log callback isn't called. I don't fully understand it. We haven't looked at this, but this was happening yesterday too, where the WASM implementation was giving us better logging. So did we just fucking do something stupid here? GL debug callback, enable GL debug. That's called, but I wonder if maybe when we added IAMGUI, he undoes this in some way. So maybe we just kind of I'm just gonna try slapping this down here and seeing if it comes back, because it didn't used to be this way. It didn't used to be this way, and I don't want it to be this way. I want nice, tasty error messages when my compilers have, or when my shaders have fucking compilers. Is that too big of an ask? Doesn't feel like it's too big of an ask. I don't know what's happening right now. Some sort of initialization stuff. So, okay, let's introduce an intentional compiler here. Let's just go into closest stop lookup and just do this. Right? This should give us some problems. And if it doesn't, then I'm not going to debug this right now, but I'll write it down in my brain, put it in a little fucking bucket in here that says things I have to look at, and I think that we can just pivot to the WASM version for now. And yeah, I guess we just pivot to the WASM version. If it doesn't, yeah, okay, that's fine. We just do this. It's kind of funny that the world that we're in is that it makes more sense for me to run our code in the web browser, but it does seem like that is where we are. But it's okay. It's okay. Okay, so error 12, syntax error with a bracket. So that was in probably the fragment shader. 12. There is an extra bracket there. He's got a really good point, this guy. This guy never gets off my back. He's always like, please fucking use the right values. And it's like, come on, man. Leave me alone. Leave me alone. Refresh. Okay, so our shader's compiled, and now let's try doing our test where we plan a little bit of a transit trip, and we should see something kind of pop over our whole screen, and we don't. Vertex fetch requires 4 attributes, but attributes only supply 1. Okay, so what the fuck did we do wrong there? That would be in heuristic renderer. I spelled heuristic wrong. I spelled it like the color, and so now every time I search it, it's a pain in the ass, and instead of fixing it, I just don't fix it. The alternate fix. So he says we bind our vertex buffer object, we bind our attribute object, we pass these on. Heuristic with a UGH, that's pretty funny. He's saying bro, you're asking for 4 things, but you've only given us 1. I don't really understand how that's possible. Vertex closest stop. He has 1 input vec2. Here we say we have at index 0 size 2. I think before we had these strides auto discovered, which seems like it should be fine, but then here we say we have this many, we're fucking feeding it. What is this? This is 1, 2, 3, 4, 5, 6, 7, 8 times 4, so 32 bytes. I don't really understand how this isn't fine, to be honest. To be honest, let's see if auto-selecting the stride kind of fixes whatever OpenGL bullshit is happening under the hood there. I don't think it will, but, you know, you can always dream. You can always dream. Set path start. Set path end. Yeah, I don't understand. Vertex fetch requires 4, but attributes only specify 1. Did I fuck up, buffer data? GL heuristic GL buffer data. Do I call this more than once by mistake? No, this is only called here. I guess maybe somebody else is calling it for someone else later, but I don't. Vertex attribute pointer. I'm confused. I'm confused. And another day, another getting stuck on OpenGL bullshit. It happens all the time. So here we do the same thing where we draw strips 4 points. Oh, but we don't bind any data here. That's true. It's true. What about in the other version? Renderer zig. So here we bind. We say, hey, I want to set some array buffer data to this pointer and this length with static draw, and then we fucking draw arrays. Oh, well, maybe not. We'll see. We'll see. We'll just double check that with what we're doing over here. Bind a vertex array, bind a buffer, set the buffer data to the thing and the thing. It does seem like this needs an int cast. I don't know why that's not a problem, but you know, we'll try it. We'll try it, and then he draw arrays with chords length over 2. And our chords length is 8, so draw arrays with 4 seems fine. I wonder if this comes first. I don't think it should, but maybe. Maybe. And then I guess we can also get crazy and like GL bind buffer. Oh, am I binding the buffer as the right type? Array buffer? I am. This is the part of OpenGL that's very frustrating. It's a very powerful thing to have, but when it goes wrong, it's just so, I find it so difficult to debug. Refresh. Like, I just don't understand. Start, end. Draw arrays instance. Vertex fetch requires 4, but attributes only supply 1. I just don't understand. It's fine. Dude, I'm gonna lose my fucking mind. I'm gonna lose it. Let's also look at the uses of GL vertex attrib pointer that we have in here. Like, surely we've done this somewhere. So here, when we upload map points, we do this. We create our vertex array. We bind the vertex array. So that's like, you know, we create the vertex array. We bind the vertex array. Wow. Okay. Then they bind this as an array buffer. They create the buffer. They bind as an array buffer, and they set call GL buffer data. And that's great. And they call it with this and this data length times 4, which is what we did here as well. Then they enable the vertex attribute pointer, and they enable the vertex attribute array. I see no problems, to be honest. I see no problems. Then, when we bind this stuff, we bind our vertex array. The vertex array is supposed to automatically bind the buffer. I'm like very positive about that. And I just don't, this is just throwing me off. It's throwing me off. Yeah, it's just very confusing. Very confusing. Can we do like points here? And like, he's saying there's only 1, so what happens if we just try only 1? Let's just draw 1 point and just see if we fucking get anything. Let's just start simple. Start simple. Start simple. Does that still error out on me? Set. Okay, so that is no longer erroring out of me, and we are seeing 1 point rendered in yellow, what looks to be in the middle of the screen, right? We're seeing like a yellow blob just kind of in the center, which is interesting. I would expect it to be on one of the corners of the map. It seems kind of like we might be using the wrong vertex buffer. It's possible that we replace the vertex. It's possible that when we construct this thing, when we construct whatever we construct next, we forget to bind the correct vertex array. That seems possible. It seems possible. So I wonder if we can like... It would be nice if we could like intentionally unbind our vertex right here, but our API just doesn't really support that right now because it's kind of fucked up. But that's okay. It's fixable. This is solvable. So given that we know that the point is being drawn in the middle of the screen, we can get a pretty good guess at which one of these assholes is messing with us. Right? It's going to be somewhere. Renderer? Here, he's trying to render coordinates in the view state center. Okay. So he binds his element buffer, but he never binds the vertex buffer here, which is a good clue. Which means that probably it's still bound. So let's go in here. Let's just go GUI GL bind buffer, GL array buffer, self VBO. Because we are changing the thing sometimes. We are changing it. So here we can just kinda we'll here return both the array object and the buffer object. Like this. And then here will be like points, and val is we'll call this obj, and here we get obj 0 and VBO is obj 1. And this is like this, I guess. I don't know, we'll figure it out. All right, let's see what happens now. Okay. So now we're just not seeing anything drawn, which is kind of interesting. To be honest. So what the fuck did we change here that would cause such a major kerfuffle? So this guy does return VBO, VAO. Here we have VAO, VBO. Okay. And it could be that things are going poorly somewhere. Trying to figure it out. I guess. We have to just start bisecting, I guess. So here in our render function, let's try to avoid doing anything but rendering the bare minimum. You know, just in case that's related. Fuck off. What have I just done? There we go. So here we'll just say like, if true, return. Let's just kind of see how that affects us. I accidentally undid this meter metadata input here. Which is annoying, but it's fine. We will live. Okay, so here we're still in trouble. Attributes only support. Okay. But, I mean, this is a good sign. It's actually a good sign because it means that, like, something that we're doing here is, like, not doing what we expect. Or if we go back here and we comment the part where we rebound the buffer object, I bet we will see it start working again. Which kind of lines up with the theory that someone's overwriting our vertex buffer object and we don't want them to. Yeah. So the fact that the map's back there kind of does indicate that. So now we just have to figure out who that is. So let's start here, and we'll like disable all renderers that aren't the main renderer, and we'll kind of start pulling them back in as we need to. So here we will get the shit out of there, and then we have self dot bound renderer. Okay. We'll try this again. And I guess the next step is to look at any calls to like buffer data where we're trying to upload vertices. Who knows? Who knows? Okay. So let's just start looking for GL buffer data. Here's an example. Time range. We're not calling that. That's not being called, I think. And specifically, we're looking for buffer data associated with array buffer. So here's one possible culprit. Comment him out. We'll see what that does. One possible culprit for sure. All right. Okay. I see. I found it. Okay, so it's that when we call render chords here, we bind an element buffer, but then we reset our array buffer. So here we need like a custom, we need like a short-lived buffer object here. Is probably the problem here. So we'll do this. GL GUI GL create buffer, and then we'll say GUI GL bind buffer array buffer, and this is VBO. And then after this, we say GUI GL bind buffer GL array buffer self VBO. And that should make it so that we stop fucking clobbering our own fucking data. Should be. And then we can go back to enabling our renderer, and hopefully he won't be just like fucking fucked anymore. So we should still see the map drawn here. Big win for us. That's a big win for us. I kind of want this to use like a long-lived buffer object like this, just because I think that will avoid like some like spam of JavaScript object creation. So you can just kind of do this. So here we actually just say custom VBO is equal to this thing. This is poorly named, I understand, but we're prototyping. And then we should be able to go back into our app Zig, and we should be able to start uncommenting stuff and have it go back to working. Okay, so texture renderer, we set something to like equal undefined here earlier. So let's kind of put this back to texture renderer and heuristic renderer. And then these guys we can like uncomment, and then hopefully everything still renders okay. Hopefully. Okay, set path start, set path end. I don't really know why we've got something else happening here where the path start and path end aren't being rendered anymore. Those are supposed to be rendered in red. Oh, because we didn't uncomment the fucking rest of everything, right? If true, return. Uncomment this. And we should be back in business, baby. We should be back in business. Refresh. All right. Set path start, set path end. And now we should see, let's go back to trying to draw our big ass quad now in our heuristic renderer. So let's go back to trying to draw triangle strip 4. And if everything is good, then we're good. We should see like basically the whole screen should get covered with crap. Once I hit start and end here. Hell yeah, baby. Let's fucking go. So this is exactly what I expected to happen. That's what I wanted. But it shouldn't be yellow. The fact that it's yellow is a fucking problem. That's not good. So let's go back into our closest option here. So this is supposed to take in the input thing over width and height. Now, we don't ever set width and height. So width and height are probably getting set to 0, and then red and green are probably getting set to infinity, and then the out color is probably getting set to yellow. So what we should do instead is we should set those fucking values. You know? If you want the value, you should set it. And I've been saying that. So width and height should go like this. We store these things like this, and they need to be width and height. And then down here we say, let's see, maybe we bind when we actually can just set these here. So we can do like GUI GL bind program, use program, nice. And then here we just say width dot set metadata width and height set metadata height. And that should give us like a nice little colored square. Nice little colored square if everything worked. And you know, you never know if everything worked, but sometimes it does. So let's just try, you know, start, end. Oh yeah. Oh yeah, look at that. Look at that beautifully colored red to yellow to green. That's exactly what we want. So this now tells us that we know where the corners of this quad that we're drawing over the whole map are. Which is good. Which is good. So now we can go back to doing actual work. The actual work is going to be in our fragment shader. We wanted to bind the sampler. Texture, I guess we'll call it. And we are going to basically bind our input data as a texture, which means that here, I guess we're going to have some sort of like long-lived texture like this. And we're going to create this thing by doing like GUI GL create texture, which doesn't exist right now. That's great. We have to bind it. We have to make it. So I think we have like setup texture here, which creates a texture, generates maps, and returns it. And we only call this in the context of loading satellite images right now. But we can just kind of make GL create texture. GL, I guess we were gonna call this something kind of fucked up because this is doing a lot more than just like creating a texture. I guess this is taking an image as an input as well. Let me think about this for a second. I think that we want just to create bind. I think we just need to create all of these things manually. That's fine. So we need create texture. Which is gonna do take in no inputs, and he's gonna basically do this part where he creates the texture object and then makes a GL object and then you know sends that shit over. We're gonna have GL bind texture, which takes in a target and texture, and that's gonna do this. And then we have text parameter I. I guess maybe we'll use lowercase I here. And this is the target param value, I guess, something like this. Target param val, boom. And then the last one is text image 2D. So this should be GL text image 2D, and he's gonna take in, who fucking knows, dude? What fucking... He takes in... I mean, what are we doing here? we are passing in like an image object here that is coming from like a bitmap or something. Here we want to pass in like a bucket of bytes. So here I guess we can maybe assume data format. So this is probably using this is probably WebGL2. Yeah, it's taking in this version. Target level, internal format type pointer len, I guess is what we'll take in here. And this is basically gonna call this target level internal format type. And then here is the tricky part, is we have to figure out how to like create this thing from a bucket of WebAssembly memory. So he takes in like an image that can be one of these things. So we need to create image data, I guess. How do I create an image data? And does this thing have like width and height? We actually have to pass in width and height here as well. I guess we just pass in width and height and infer length from that. So how do we like image data? MDN. How do we fucking make one of these? So we create a uint8 clamped array. Where's like the fucking constructor here? Data array width height. So data array is a uint8 clamped array. Okay, so we do something like, given this thing, we create a uint8 clamped array from pointer, and the length is going to be width times height times 4. We are going to assume RGBA. So here we're actually going to just force this type, this format, as this GL RGBA. We're going to force that, which is fine. We'll live. Now we create an image data from this thing. So image data width height from, so width, height, and buff. And then we should be good to go. Should be. And I suspect that we don't have to generate bitmaps. I suspect that is true, so I would like to see if we don't do that with the satellite data, is everything still good? He's mad because at heuristic renderer, so we have to, I guess, create, set the bindings up here. So we basically take all of these guys that we just added, and we kind of shove them in here somewhere. So we already had bind texture, I guess. We did already have that. But this is just wrong. The old version, so, or the new version. Probably the new version is wrong. That's true. But that's okay. So we'll just kind of shove the rest of these guys in here. So it was only 3 parameters, I guess. So it's this, and this. And for each of these guys, we are going to bind them to WASM handlers dot GL create texture bind WASM handlers. Boom. And we do that again here and here. Oh, fuck. Copy, paste. Paste, and then we just have to update this to be GL text parameter I and GL text image 2D. And I had text parameter here, which is wrong. It should be text parameter. All right. And then we set up, I guess, the callbacks for these in GUI bindings. Do you find yourself talking to yourself when you're not streaming? Only if I'm practicing for streaming, which does happen sometimes. Sometimes you have to practice. Practice makes perfect. This is going to return us an I32. this needs to take in, I guess, probably target is an I32, param is probably an I32, and val is probably an I32. Probably, and he's going to return void, probably. And then text image 2D is going to be target I32, level I32, internal format I32, type is I32, pointer is a usize, width, I guess, can be a usize, and height can be usize, I guess. Do you feel more productive when you talk out? No. The talking does not help. If anything, it makes it harder. But it does make it better for you guys. So it's worth it. It's worth it. Okay, so now I guess we have to try to call these functions. So in our thing, heuristic renderer, we have like const text is GUI GL create texture. And then we have text equal text. And then down here, we're going to bind the texture. GUI GL bind texture to GL texture 2D with something, I guess the self text. Boom. Okay, that's part one. Then we are going to let's think about this for a second. Let's think about this. Do we just draw? I'm actually okay with just binding in the existing thing we were doing before. So before we were basically creating this like buffer of RGBA. This could be our RGBA, right? The item position and its closest point. That kind of fits already into the format we were talking about. So all we have to do is just, instead of this getting uploaded to like a vertex buffer and an element buffer, we just like create a texture for it. So we create a texture 2D of self text. And I guess we probably just fucking set the data. So we might not even have to bind it first. This actually might just come for free. I guess no, because there's no element in here. So target level 0. I guess we'll just copy our existing thing here. So how do we do this in this world? 0 GL RGBA texture level internal format type. So this is gonna be unsigned byte. Not this GL. This is GL like this. And then we have pointer width and height. So this is gonna be vertex buff pointer. Let me think for a second. This is the closest stop lookup closest stop lookup X samples and closest stop samples Y samples. This is what we were uploading. GL has no element RGBA, so we have to find that thing. So GUI utils, I think it's GL utils. Here, we copy paste whatever value we get from this website. RGBA. Where is the like unsigned int? Here. All right, where does he say RGBA in here? Blah 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 RGBA. Whoop. This is how you write code, for sure. Has no unsigned byte either? Really? We haven't used that one yet? All right. That's fine. Pub const unsigned byte is equal to this. All right. If you say so. Pointer is mad because he expected a usize. That's a pretty good point. Our GUI bindings, it does seem like this pointer should be like a const u8 or something. I don't know. I don't know, man. We can pointer cast that shit. Okay, and then to prove if this works correctly, I guess we run it now just to see like how like make sure we didn't like major fuck anything up. I think that we should just see, something that boots and runs. Okay. And we actually need to, when we construct our texture, we should copy the parameters that we use in index.js. I can never remember why. I just know that these parameters are like important. I just know that, so we have to put them in. It's something to do with like bitmaps and stuff, and like I don't know. If you don't set them, then like if I remember correctly, it will try to use these like it will try to use bitmaps that don't exist, and you won't see your image or something like that. Is my recollection. That's okay. We'll figure it out, and it will take a while, and that'll be okay. GUI.gl, and then this gets case swapped. So find dots twice, replace with GUI.gl, and then do that again. Hell yeah, baby. Now we need these texture wrap S and min filter and mag filter. So texture wrap S. Here we go. Perfect. Perfect. So I guess go to the end of the word and replace with pub const. Okay, and then here can we like end, right, delete till equals, go back. Boom. All right, much better. Much better. And repeat and linear. So this is repeat. And linear. All right. All right. So now the last piece here is that in our fragment shader thing, we need to bind the texture that we're using. So here we need to be like, I think it's active texture 0 or something. We can look. This is already somewhere. It's going to be in our like texture renderer or something. We activate the texture and we bind the texture, and that's it. And then do we set the parameter? We set the texture parameter to 0. All right. So inner text, and then this is fine. So we say, yeah, right. So if I remember correctly, it's like you have a uniform. It's something like uniform sets this to like 0. Then you like activate 0, and you send this to like the texture data or the bound texture, and the texture has been bound with image data. If something along those lines. Wow, can anybody read this? Because I can't. I don't know what I wrote here, but sometimes it just feels like you should be writing something, you know? Okay. So this guy now has this texture parameter that he needs in here. So it's texture is texture. And then here we actually need to set the width and height as well. So I think this is fine. And it's just here when we feed this thing, we have to say self width. I guess we bind the program. And then we set the uniform. So we say self width set. And this is X samples. Oh no, the width and height are in meters. I forgot. which means that we have to we actually need like the texture width and texture height as well. So in our fragment shader here, we need to know this is the width and height. We can say uniform int text width and text height. Except for now, I'm just gonna hard code those because I don't want to deal with it. In fact, we can just sample relative to RNG. Let's just do that. So it's like, how to do this? Texture. Texture. I'm so fucking stupid sometimes. It's like image GLSL. It's just you set the texture. So let's maybe set. We'll try to color based off of interpolated distance to stop. So here we'll say text val is equal to texture from basically this. Then we can say text length text val, and here we actually want like just RGB and alpha, right? Then we know that we want to multiply this by like 0.001 or something. It was a float. And then what was our formula before? It was like R is equal to 1 over 1 plus dist. And B was equal to 1 minus R. And then we put R and B in here. This is what I think that we had before. And so that should give us like a little heat map of the closest stops. It should be a little bit off, but you know, whatever. So then we have here texture equal texture, and texture was an int uniform. Yeah, so here I guess texture doesn't come from a float uniform, it's int uniform. So int uniform and float is int uniform. Okay. Okay. So now we hope to see like something that looks kind of like Vancouver, like to some really fucked up extent, but more likely we're just going to see black. It's more likely just going to be crap. Oh, nice. Dimension mismatch. So at line 13, texture function name expected. I guess it's probably true that you can't say like texture is a function, so using this as a variable name also doesn't really seem great. So here we need to go back to our heuristic renderer, and here we saw texture. This should be U texture. This, all right, let's try again. Round 2, baby. Let's go. Refresh. Okay. Wrong operand type. No plus takes const int and float. Okay, so this is at 15. That's a good point. So we convert these both to floats. Try that again. Round 4, round 3, round 7. I don't remember. Who fucking knows, man? Who knows? Okay, so we at least made it to here, and then let's try rendering this thing, and argument 1 is not an object on GL text image 2D. So probably here we just forgot to... Argument 1 is not an object. GL texture 2D. Oh, image data. Oops. Did I have, is it buff width height? Did I get this wrong? I might have. It happens. It's been known to happen. We've made mistakes around here, around these parts. Okay, so now this thing's just fucking red. No texture bound to texture 2D 0, so that's not good. Texture 2D at unit 0 is incomplete, but bad bitmap dimension or format, also not great. So when I uploaded the texture, did I not bind it first? I did bind it. Then I set it. Maybe after I... No, then even here... Oh, it's not bound here. Which is probably a problem. It's likely a problem. Likely a problem. All right. Set path start, set path end. So now we're not getting spammed with OpenGL errors, but we are just seeing red, which isn't really great. That's not really what I wanted. Maybe we can just render what we get from the texture directly. Let's just kind of say like, we'll comment this out and let's just see texture, sample from you, texture at vec2 rg. Because that did seem like we did have, when we didn't sample the texture, we got like like the colored gradient on the quad that looked kind of reasonable. So that should be in the range 0 to 1. And so we should be sampling this texture 0 to 1. That is interesting. That is interesting. So what we can gather from this is the sample, the distance between these points, I think, does give us approximately the right sample size. We can confirm this by going into our color, or what is it? It was like a closest stop lookup. And this 200 by 200, we can drop this to 25 by 25 and just kind of see what type of effect that has on the output. We should see that we just get like a pattern of 25 by 25 now. Maybe. So refresh. Refresh, and let's just kind of see. Yeah, you can see that like the frequency of this has gone down by a lot. So that is a good sign to some extent. Also, the fact that this data is not just like black is a good sign. So we can actually we can confirm here if we just set every single value to like 0, right? We should see that this screen just turns totally black. So let's just take a quick little peek skis there. Refresh. And start and end. Completely white. Oh, because alpha is 0 and probably, like, let's try setting alpha to 1. Let's just double check that. Double check that. Double check that. Boom, 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 boom. Start to end. Okay, this is not what I expected. Not what I expected. I guess we are claiming that these things are unsigned bytes because we copied that from some image inputs that were unsigned bytes. I wonder if that's a problem here where our image data is being constructed from a uint8 clamped array, which kind of means that all of these things, this is expecting RGBA as uint8. Which is not really what we want. Can we do texture data with floating point numbers in WebGL? If not, that's going to be a bit of a problem. You can do, okay, float 32 array. He has RGBA inputs, and he part of the WebGL API exposing floating point pixel types textures. So you can just throw GL float in there. That makes sense. That does make sense. This isn't text image 2D, so that's probably internal format. Let's just kind of see if this does what I want. Where are we at? He might get mad because the input data was uint8 clamped array, which might cause problems. But it is just black now, which is what we wanted. Let's try making it like blue or green. That will make it green. Let's try making it blue. Let's try making it blue. If it's blue, then we're chilling. If it's blue, then we're chew. No, that doesn't make any sense. Okay, start, end. It's still black, so that's not good. That is not good at all. Not good at all. So index.js text image 2D. I guess we have to say image data. He said that we can use the image data, but image data has to come from uint8 clamped array, which is annoying. How can we like text image 2D with just like arbitrary shit? So we can do pixels. Pixels, pixels, pixels. Pixels, pixels, pixels. Can be one of these. The following types can be used when width, height, and border are specified. Float 32 array. Float 32 array, please. And so this is expecting length probably should not be multiplied by 4, would be my guess. But maybe it should be. I don't really know, but we'll find out. And then this is if width, height, and border are specified. So here we need to use one of the versions of these that are width, height, and border. Target level, internal format, width, height, border, format, type, offset. Width, height, border, format, type, pixels. Here we go. Internal format, width, height, border. Width, height. Okay, so before we were doing this one. So it's width, height, border, format, type. Format, type, pixels. Okay. Let's try that. Give me some blue, baby. I like Zig. I like it. It feels comfortable and efficient. Not very restrictive. It's pretty good. Argument 1 does not implement interface uint8 clamped array at 165. That's true. We do just want to return buff here now, not image. This guy's always a whiner over here. He's like, well, I wanted a uint8 clamped array. It's like, fine. Like, I don't know why you gotta be like that. Why you gotta be like that, bruh? Alright. It's black again. I wanted blue. Because invalid internal format type. Okay. Internal format. Invalid combination of internal format, format, and type. Okay. Okay, that's fair. So here he's saying internal format is RGBA, format is RGBA, and then type is float. Right, if we go into GL utils, we will see that float is 1406, probably 1406, and that these two are probably RGBA 1908. So he can't have RGBA floating point? Why not? I mean, we do see OES texture float extension. So how do I use this? Is there an example? We just have to call this somewhere, maybe? Like, I'm just like, console log x, like, I don't know, man. I don't know. Don't ask me. All right, so we do start, end. So he doesn't like that. GL is not defined. That's a really good point. Oh, whiner, this guy, man. He's always whining. Always whining. All right. Start, end. So he does say that that is null, which probably indicates that that's not available. So how do we look at like get extension? This also is maybe WebGL, not WebGL2. This is WebGL. So it is like WebGL2 floating point RGBA texture. Like, hello? Uh, hmm. I mean, we could also try. It's possible that maybe this is backwards from how I think. If it's Little Indian, let's try making like the two corners of this thing on. So this should be red. This should be red. There's a chance, and then let's go back to index.js. I'm not really too happy with this. The extension thing didn't feel right. So let's go back to like this. Oh no, wait, but he was saying that the internal format combo wasn't good. Right. That was the error that we were fighting with. Right, so here I expect to see that that is still going to be the case, actually, yeah. So can we say, and can we look this up? WebGL, and then we can say like float. I went ahead and brute forced it. Sick. Oh, so maybe the internal format has to be unsigned byte? More in the spec. Oh, this is what I want. All right, let's see. I guess we can read back on this. So internal format, possible values for WebGL and WebGL2. Other possibles in WebGL2. So are you like RGBA? Looks like these are like, oh, here we go. Here, whoa. RGBA 32F. Okay, wait, we can try that. RGBA 32F. So where does that come from? WebGL2 spec. RGBA 32F. All right. Fucking run it. We run it, baby. What is this called? GL utils. And then was that for internal format or not? This is for internal format. Okay. So for our format, we still use float, but for the internal format, we use that thing. So text image 2D internal format, we just pass in here. Okay. Maybe. Maybe. You never know. You never know. All right, start, end. He's not bitching at me anymore. Oh, he is. He is here. Desired upload requires more bytes than are available, so I have to multiply something by 4. Okay. So let's just times 4 here for a second. I know that's not right, but it does kind of seem like... Seems kind of like that's what he wants, man. I don't know. I don't know. All right, so start, end. Is he complaining? It's not red. Okay, so now we're saying draw arrays instant. Texture 2D at unit 0, min and mag filtering is not nearest or nearest bitmap nearest. Okay, we're definitely getting closer. We're getting like errors that are kind of sane, to be honest. Nearest or nearest bitmap nearest? So do I do that in index nearest? Do I do this anywhere? No. And the texture format is not texture filterable. Okay. So I remember, I've seen this before. And I remember this being related to like just, you know, some bullshit that I don't understand. But instead of reading, we'll just do this. And for now, because I'm cheating, we're going to do it like this. Because I don't want to set up the bindings. And then it's like this GL dot here and here. Oh my god, what a burp. Sorry, guys. So here we can probably do like GL underscore replace with this dot GL. Probably with another dot in front of it. All right, let's try that. Let's try that. We'll see what he complains about this time. And another day, another OpenGL eating more time than I wanted him to. So now he's saying texture 2D unit is incomplete. Magnification filtering is not nearest or nearest bitmap nearest. I did not write nearest on both of these. I did not do what it asked me to do. And that's on me. That's on me, you know? Sometimes you gotta do what it wants you to do. There we go, it's red. Very good for us. That's very good. We finally have some data uploaded. So now let's go back here, and can we go back to putting the like data that we actually care about in here? Oops, like this. And let's just kind of see if that that indicates anything sane. How does it look, you know? Just kind of, let's take a peek-sees. Let's take a little peek-skis. Okay. Okay. So this is probably indicating, let's try, here's what we can do. Here's what we can do. Let's go back into our fragment shader. And let's kind of go back into closest lookup and turn this back up to like 100 by 100. And then let's go back into our fragment. Was it fragment closest stop? And let's go back to this version of the code that like tries to sample, you know, the texture that we passed in. So this is going to be X, Y, and this is, no. Text val comes in from XY like this. All right. So we're hoping to see some sort of like redness that kind of follows the shape of bus routes, kind of maybe a little bit, maybe, you know? Doesn't have to be great, it just has to look something like something. All right, start, end. Okay, let's fucking go, baby. We finally got here. Okay, so here you can see like individual samples. You can tell that they're like very, it does look like something of something, right? You know, it doesn't really, it's not that sane, but at the very least, it like, you know, it follows the shape of Vancouver. to some extent, right? It's kind of like tracing the bus routes, which is what we wanted. And now the trick is to replace this with the actual thing we want to do. So we are an hour and a half in, and we are now ready to do some work. Not that this wasn't work, but this was kind of like visualizations for the work. Okay. So we just want to, we're actually almost there. In fact, we probably are there. We right now are at each pixel. Each pixel was indicating the direction. It's the blue and alpha values in the texture are the distance to the closest stop. And we can now just normalize it because the x and y values are their position, the position of the sample. And so we can just do the work that I wanted to do. So we can do something like, we can like dot product our position. So we'll say like vec2 sample pause is, x, y, right? We'll say that the texture value is this, and then we can say vec2, oh, this is our pause, fragment pause, I guess we'll call it. Right? Then we take like the sample pause, and this is just text val xy. And so we can kind of like dot the fragment position onto the sample position. But we want, then we need to divide this by length fragment pause. Sorry, thinking for a second. Just the sample pause. No, hold on. You can't dot product positions. What am I fucking talking about? What am I talking about? Let's fucking open this again. So we're saying like, we have a point here with a vector pointing towards a bus stop. Then we have like us, and this is the sample we're looking at. So we want to do us minus sample, which is going to point like this. And then our distance, our guess for the distance is just going to be this. Right? So we do us minus sample dotted onto the direction. Okay. So, like, fragment offs is fragment position minus sample position. We have to be careful here. The sample position is in meters. The sample position is in meters. Our position is in normalized space. What the fuck am I looking at? Fragment pause. What is width and height here? Oh, because our input is in meters, then we divide by it. Okay, so we want actually, we want to work in meter space, I guess. So we'll call this like frag pause meters. Oh, we have that. So this is, whoa. Frag in. That's what we want to look at. So frag in minus sample pause is the fragment offset in meters. Yes. Okay. So now we have the closest point vector is like a normalized version of this. I'm assuming that normalize is a function in GLSL. I don't actually know. Normalize. Okay? So now, if we're just trying to do this dot product, all we have to do is like sample, we have like sample pause plus dot the closest stop vec multiplied by the dot product of us minus sample, which is, we called this, onto closest stop vec. And this is now, hold on, thinking. I think we just have to subtract this. So we have like closest stop. Yeah, we want like the unnormalized version of this actually. So we have the closest stop vec, and then we subtract the normalized version of this times our distance, maybe, and then we take the length of that. I don't fucking know, man. Like, this is some math, maybe. Let's see if that works, and if it works, then we say, instead of thinking, we say that we did it, and if it doesn't work, then we think a little bit harder. But what we're hoping to see is, before we have this like pixelated version, I want to see like a smooth version. Instead, we just see blue. It's just blue. So we have to debug. Optimizing way of thinking. Yeah, exactly. Okay, so maybe let's start by just showing the fragment offset in fragment offset meters. I wonder if we can just render this instead of the distance. Frag offset times 0.001 or something. Because that we should see is that we should see, as we get farther from the center of the samples, we should see it become more and more blue. Instead, he's fucking mad because you can't convert from two-dimensional vector to float. That's true. That's a good point. That's a good point. Let's try again. We always try again. We go, 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 go. All right, so start, end. Okay, so that is something periodic by sample. It's oddly not centered. That's pretty surprising, actually. Oh, interesting. It actually gets offset from the center of the pixel the farther we get from the center of the screen. That's interesting. What am I looking at? What am I looking at? Okay, so this is supposed to be, we sample this thing, we have the sampling set to the nearest pixel, so we pick the point, the texture point closest to us. Okay. I think this isn't what we want, actually. Because I think if I remember correctly, our corner points, we actually sampled the corners as well. So we actually tried to sample like this. So if our thing is 1, 2, 3, 4 wide, we actually have to like do some sort of like intelligent conversion here. So let's think about this. We have the width of the thing. So this is width, like, say this is width 5. And we have number of samples, which we don't use anyway. Oh, I guess we don't need them. Yeah, that's true. So the number of samples here is also going to be 0, 1, 2, 3, 4, 5. Now our conversion here has to be related to this number of samples. So we'll call this X samples and Y samples. Then we define this as like our distance over the width. So if we're at like, if we're at like 5 over 5, that should sample index 4. So times samples minus 1. Right? We have 5 samples. We want to go to index 4. I think that's right. Then we probably have to round. I guess maybe we want to. We need to do bilinear interpolation, which we're not doing right now. Right? Like here, we need to somehow like use these 4 pieces of information if we're like in here. But for now, it might be interesting to just pick the closest one. Let's just do that. We'll pick the closest one, which means that this gets rounded. So that sounds right. So here we just multiply int x pix is just the, I guess we'll call it x sample, is going to be x times x samples minus 1. And then we have int y sample is equal to y times y samples minus 1. And then if we want to specifically fetch, we want to fetch a specific pixel from here, we do, I think it's texel fetch or something. Which is at this point. So it's going to be ivec2x sample y sample at LOD0. And then here we'll say this is the text val is equal to this. That sounds right to me. And then here our sample pause is this still, our input position is still this. So the rest is still should work okay? Maybe? I don't fucking know, man. Oh, we need to set the x and y samples now. Those are not set anywhere. So here we want like x samples, y samples, x samples, and y samples, which means we have to need them here as well. X samples, y samples, and these are actually int uniforms like this. From writing an OS to a Rust and a map in from writing an OS in Rust to a map in Zig. Yeah, I'd say that it wasn't really a linear path, but we sure have kind of progressed in that direction. We sure have. Those are 2 samples for sure that we have been on. So now I have x samples set this. And again, but with y. Oopsies. Should be like this. Boom. And I guess we'll kind of see what that looks like. I suspect that that'll be okay, but you know, we're usually wrong around here. We make a lot of mistakes. Those are 2 samples I took, so I'll interpolate. Maybe use nearest sampling instead of linear. Just like it told us. He's mad at fragment. I should have read the error message, actually. That would have been helpful. If we read the error, we can make better decisions. So at 16, wrong operand type. No multiplication list between float and int. God fucking damn it. So here we just need like x times float y samples, I guess. And then here we need to round these things. We did say that. And then do we need to int cast these after? Or do they get autocast? We will find out. We will find out. Okay. Equals cannot convert from float to int. Yeah, so we just need to int cast these as well. Bump, 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 bump. I wonder if it's stupid. Like, the way that we're embedding the shaders in the Zig executable means we need to, like, relink every time we do anything, which is, like, kind of a little bit of a pain in the ass, but not enough for me to want to change anything. Okay, so that feels better. So this is what we expect, right? Since we have a sample right here in the corner, we're expecting, like, a very close thing right in the center. And now we are seeing that these, like, red hotspots are no longer, like, drifting as we go. So this is very good. That means that we have a pretty good idea of, like, which sample is which is pretty sick. And so now, let's go back to trying to use that information in some way. So we know that the sample comes in meter space. We know that we have our distance from that thing is pretty, like, it's going the right way. So I guess we can go back to trying to integrate this thing somehow. I don't really know what this will do, but let's just take a look and see. It's likely that the math for closest stop calculation, like, is just wrong, but we'll see. A, B. Okay. Very interesting. Very interesting. So this makes sense, I think. I'm good. Okay, so I don't know why, like, alpha blending isn't working here. Oh, probably because we have the alpha fixed to 1.0. Can we set this like 0.5 so we can see the map underneath? It does make sense that there is a horizontal line here. That makes sense because we are only, like, using, like, a dot product that maybe doesn't make sense. Maybe this should be scaled somehow with distance from the point, but I don't think so, actually. Yeah, so I don't know, like, the alpha blending on the WebGL version doesn't work, but we can probably run the non-WebGL version now without, like, a major problem. Oh, I guess all of the fucking OpenGL calls that we added aren't going to be implemented here. But I guess it just makes sense to implement them. Fuck it, you know? Right, so we need GL create texture, GL text parameter I, and GL text image 2D. So let's go to the named, or can we, like, WebGL alpha blending? Maybe there's just some fucking thing that we have to, like, it just doesn't seem like it's working right. GL, it's like WebGL alpha not working. Like, let's Google it that way. WebGL 2 alpha. Okay. Alpha in back buffer. This sounds familiar. Turn off rendering to alpha. Telling WebGL to only affect the alpha channel. I guess we'll try setting pre-multiplied alpha. I don't really understand, but I remember. Yeah, I just don't understand. Let's not pretend anything else. So this is this one. We're gonna want pre-multiplied alpha is false, which is true. I think we are not pre-multiplying our alpha, so it does make sense. This isn't what I want, huh? I want the WASM version, and I want to run Python. Okay, let's see if that does anything. Nope, still not what I want, right? The fact that it's, like, just not fucking... Tell WebGL you don't want alpha in the back buffer. What is back buffer? Clear alpha at the end of your rendering. Clear the alpha once, not rendered to anymore. I don't understand, like, maybe this feels like it might be relevant as well. Does WebGL need GL enable GL blend? It might. That sounds promising, huh? That does sound promising. But we will find out. I'm going to try whatever the fuck I just changed there, which probably won't change anything because I'm just kind of arbitrarily doing shit. And let's try GL enable GL blend. Because that does feel like something that we would need, to be honest. I've had to turn that on in other OpenGL contexts, so why not in WebGL? Ah, thank you. Thank you, thank you, thank you. Big win. Big win. So just get rid of the rest of this shit. Thank you. Okay. So now the question is what the fuck did we do here? Oh, interesting. Interesting that it needed more than that. Probably the blend func, right? If I remember correctly, the blend function has to be set every time. But we probably don't need it to say apply alpha with the rest of the page. There we go. Okay. So let's see. Here we say, hey, this is the distance to the closest stop. And we want to subtract in basically like us along that vector is what is supposed to happen. So our offset from where the sample came from, dotted on with the normalized version of this, is an important thing here. I think that I missed a normalize. I don't really know if that will make this much better or much worse, but it didn't look right. It did not look right. All right, let's try this again. Start, end. Okay. Okay. That's definitely something. Let's try increasing alpha a little bit, and then can we make it so that the red is a little less aggressive? So if I want red to be less, then I want this number to be bigger. Bigger number in divisor, smaller number in real number. Okay, refresh. And let's take another look skis. Okay, so fuck, it's hard to see the underlying bus routes in this scenario. So here the bus goes like, it's kind of like along this main street. And we're clearly seeing some problems here where I guess the sample here is pointing up and to the left. Or something? Why is it... Okay, so this makes sense, right? We're seeing like a bit of like a hotspot here. I guess I don't understand something like this, right? Where the bus route is coming like along this street probably. So the sample here is probably pointing to this bus stop right here, right? Ah. Right, so the bus stop is very close here. And so as we hear the sample, we sample and we say like, hey, it's a little bit down to the left, right? And then basically everywhere within this sample, we are moving a little bit down to the left. So it does seem like we probably just don't want to only use dot product. We probably want cross product as well. Right? Is that... Can we think about this in some way? So like, we have this box. We have sample is here. Bus stop is here. Okay? He's saying, it's over here, baby. And we're just saying like, okay, I'm over here. So I guess we kind of like project this onto this thing. And it's like, that doesn't seem right. We also... Like, what are our triangles here? Right? Like, we have, let's draw like a little farther apart. right? So we come like here. We have this, we have this. So I guess we want this. Which seems like drawing it like this makes me think that it's inverted, so let's not do that. We'll draw it like this. Right? We have this, we have this, we want this. So we calculated this by basically subtracting this projection from this distance. Great. And I guess we want to add this distance. Yes. Yeah. So wait, let's think about this. So yeah. So we take like this vector, and then we subtract this distance here to make it shorter, so it becomes this vector, and then we subtract this distance here to kind of make it point like this way, and then that matches. Yeah, so we just have to subtract also closest stop norm. So we want to normalize the closest stop vec. And then is there actually do we actually need these projections? It does seem like we just subtract this thing. It does seem like that. It does seem like that, huh? I am down to bite the bullet there. So now the problem here is what happens when it's like really far. I guess we still just subtract. Yeah. I was getting too fancy, maybe. That seems very possible. Very possible. Let's see what happens if we do that. I guess initially I thought that it was just like follow arrow, but it's not quite that simple, I guess. Maybe it's more simple. Aha. So this is why I didn't like that necessarily. Right, so I had this thought that kind of like if there are like stops along here and like this guy's kind of pointing to this one, this is pointing to this one, this is pointing to this one, like maybe we'll like miss one or something, right? I kind of had this thought that made more sense, but it's very possible that these are the like stops everywhere. I don't know. I want to try reducing the sample size here and just kind of see what that looks like. So closest stop lookup, like we go back down to 25. Let's just see what this looks like. Yeah, see, this doesn't feel right to me. But maybe that's just like a result of this, like the way that like sampling at this resolution might just fuck you. It does just fuck you. What if we go even more samples? 200 by 200. What do we want the red to show? I'm not sure, to be honest. Part of me feels like we should see some sort of like kind of like just like I thought that we might see like a contiguous like kind of like red-ish around the bus stop and bluish far from the bus stop. I wasn't really expecting such like red circles. I wasn't really expecting that, but maybe that's reasonable. I also want to see what happens. I think that we definitely want to blend in the other, like the surrounding pieces of information, right? Like we don't really want these like hard borders, like this. Like that's definitely not correct. So what does that look like? We can maybe look at this as like, so this is our position. We'll kind of say like top right is, I guess we'll say this is like our okay, textile fetch, we get X sample and Y sample. Here we multiply this by the number of samples, right? So we'll say that our, sample space X is this, and the sample space Y is this. And we want like top right is the int ceil X, and is it ivec2? Int ceil Y. Okay, then what? Here, I guess we want like we can just say that the vec for top right is texel fetch u texture at LOD 0. And then here we can go like top right, bottom left, bottom right, top left. So top left is going to be, bottom left is floor Y. And then left is floor X, like this. Then I guess we kind of just do this for all four. And average them? Textile fetch typo is killing you? Fine. It's pretty bad, huh? So maybe we like scale this with the distance from one to the next, like which one we like best is the one that's closest. That might be it, or maybe it's, I mean, averaging doesn't seem crazy. Doesn't seem crazy. So maybe we do something like, or maybe we take the minimum? No. I need to think about this. So let's just start with like a simple case, right? Everything's pointing inwards. So if I'm like here, what do I expect to happen? I don't even really know what I expect here. I guess here I expect to all four of these guys to convert. If I'm like in this box like this, I expect all four of these to convert to the same thing. Right? So I take this vector, I add this, and it turns into this. Right? All these are pointing to the same thing. Great. So here I just average all four. Now what happens if we're kind of in a different scenario where these two are pointing up to this thing over here, and these two are pointing like to this? if I'm here and I average this, I'll end up like over here. Which is like maybe okay. Maybe, I'm not sure. There's also something about the fact that I don't necessarily think I want to store the exact position of this. Part of me kind of feels like just each point should point in the direction. That's kind of like more what I was imagining at the beginning of stream. And in that case, the math of like the let me think for a second. So he's saying, I think it's over this way, and I'm over here. Then I'm just like, fucking figure out. This is why I was doing like dot producting before. That's wise, because I was thinking like, if this guy thinks, if all this guy knows is that point go that way, then I have to do something perpendicular to that. Right? Because I don't know, this doesn't know if it's like really far that way or not very far that way, right? And if it's like really far that way, then it's effectively parallel. But if it's not very far that way, this like horizontal movement has like a really big impact on the new distance. That was my initial thought. Now, if we go back to trying to like, if we go back to trying to blend these things together, what the thought was that say the point's like here, and we were looking at like these 4 samples. Based off of this information, you kind of know where the final point should be, right? You can kind of like extrapolate that by like taking the average of these or something. I get it's something like my x distance should like be like, you know, I should favor the people that are on the right thing or the person who's on the left if I'm on the left side for x, and I want to favor the top for y or the bottom for y if I'm on the, like, you know what I mean? Like it, like my I want to like linearly interpolate these. Yeah. Okay. There's something there where I want to like my initial thought was I want to bilinearly interpolate all 4 values. So I want to try that. So let me think for a second as well. Let me think. So I want my like y lerp let's say this. Let's say like top is this. And I wanted to try like lerping from top to bottom to top. Is there a lerp function in GLSL? Mix. Okay. Uh-huh. So y int terp, and the x interp is left, right, and x. Yeah, that seems right. I think. I'm not sure. These are coordinates. No, these are coordinates. Fuck, my poor little brain. So what is this? This is first of all, did I even use sample space x and y? No. So I should. That should be like this. Boom, boom, boom. And yeah, I just want like sample space top is seal sample space y. Bottom is floor. We have right and left. And then my y lerp is mix sample space. These should be floats, I guess. No. Maybe. Sample space bottom. Sample space top. Sample space y. Okay. Yep. Left and right. And then I basically do this for each 4 points. So let's do like a float disk vec. I basically want to do whatever the fuck we're doing down here. So do I want the distance? Or do I want the vector? I don't know. I don't know. We're gonna go back to the pictures. We like pictures. So as we go along here, we lerp these. I guess we just lerp the vectors. We just lerp the vectors. Yeah. Let's just see what happens if we do that. So we're gonna say void direction vect given something. And it's gonna basically be oh, this just extracts the alpha channel, the blue and alpha channels from here. And so yeah. Okay, wait. I think I'm getting it. So here we want to do. First of all, is there a way to extract like can I do like BA on these? Maybe. To convert them to vec2s? I'm hoping so. So we just normalize all of these. Okay. This is making sense. I'm getting somewhere. So we take the 2 top ones and the top 2 bottom ones, and we say mix top right and top left according to xlerp. And then interpolate between x and y. Mix returns linear interpolation. So I kind of want these just to be like according to x. So I want these to be like tr times 1 minus x lerp plus tl times x lerp. Yeah. This feels right. Then we do the same thing for the bottom. And then we do the same thing here. Is a times 1 minus y lerp plus b times y lerp Maybe this is backwards. I think it is. No, yeah. Yeah. This is the one that's higher up. This is the one that's higher up. Chat, I don't understand what's going on. Yeah, neither do I. Neither do I, I'll be honest. What I think I'm trying to do is I'm trying to basically say that given these 4 points that have 4 directions associated with them, right? So this guy's saying go down to the right. This guy's going down the left. This guy's going to go up. This guy's going to say up. I'm basically trying to like first interpolate the x values here so that these guys basically say like down and up, and then I'm trying to interpolate these to say go here, right? So here I'm saying like I get some value of like the directions in each of these corners, then I like interpolate them, and then I interpolate the interpolated. This is probably going to turn into like such total shit, but this is just kind of how I'm imagining it right now. Now, this is stupid. This whole thing was stupid. I've gone back to saying that like I thought that we don't need the actual distance, but we do need the actual distance. I'm thinking. So we also want. Okay, I'm going to go back to thinking about the case where we have a box over here, and they're all pointing really far away over here. Now thinking about this version of the thing again, instead of them just storing their directions, I think it still might make sense to. I mean, each of these guys is effectively just storing the position of the closest point. These guys are all saying, this is my closest point. But my problem with that is that I don't know, like, when this guy says that his closest point is here, I want to do something intelligent with that. That's the piece that we were missing before. And so here, if we are here and we have like one closest point here, one closest point here, and we basically interpolate these two values according to how far we are between here, then that should give us the right answer. That should give us the right answer. Okay. Yeah. Okay. So we'll go back to not normalizing these. Not normalizing. And then we lerp them. And then we just add this vector to our position. Yeah. I don't know if that might seem reasonable. In fact, we don't even add, it's just distance is just the length of the float dist is equal to length dir. That feels like it might work. I don't fucking know, man, but it feels like it might. He's mad because cannot convert from float to int at 17. That's true. I guess I just want these to be floats. And then here, I want these to be int. That's fine. We'll leave that stuff as is. I don't really fucking want to deal with it right now. Okay. Looks like it. Nope. Fuck. Sample space right undeclared identifier. True. 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 All right. What's the problem now? Wrong operand type. No operation subtraction that takes the left-hand operative type int and right-hand type of float at line 32. God damn it. TR left hand of int and right hand of float. God damn it. 1.0, baby. 1.0. It's funny that we have to wait for all of the texture tiles to load to be dispatched before it tries to compile the thing. Okay, let's see what this looks like. Now we're just seeing nothing. It's just all blue. Interesting. Interesting. Fuck. Can we like only use TR here? I just want to see that like where are we getting like fucking like anything that makes any sense? How have I like totally broken us here? Seems possible. Seems possible. Okay, so if we only look at the top right value, then we do see something sane, which is good. So it's likely some sort of lerping issue here. So can we do like try subbing in A here and just see what that looks like? So this should have like horizontal interpolation, but not vertical. It does look like the values are maybe just like overall smaller. It's kind of surprising. 1.0 minus x lerp. So maybe this mix isn't what I wanted. I kind of just want like sample space y minus sample space bottom over sample space top minus sample space bottom. That's kind of what I want here. I don't know if that's what mix was doing, but I don't really trust it because I can't fucking read. So we'll just do it by hand. Okay, this gives me values between 0 and 1. Values between 0 and 1? I guess I shouldn't trust me either, because I kind of fuck my stuff up constantly. As evidenced by this stream. But that does feel a lot more reasonable, to be honest. So let's try looking at the whole shebang now again. Aren't top right 1.0 and top or left and right, left minus right 1.0? No, because they're in a like sample space. Oh, I guess they are actually 1.0, huh? Maybe you're right. Maybe they are always 1.0. Okay. Now what the fuck am I looking at? This is a disaster. This looks like it might be the right shape, but backwards, to be honest, this part. Seal and floor. Yeah, I agree. I agree, to be honest. So, it's almost like we just want to do this. I agree with that. And then is our Y interpolator, have we got this right? Or our X interpolator is subtracting from, is R space minus left, and our Y is Y minus bottom, okay. Top right is going up, right, okay. Then bottom, so if Y lerp is 0, we should be on the bottom. So 1 minus 0 plus... Yeah, okay, so A is on the top, B is on the bottom. So this is A minus B. Why? Then why does it look like this? Why does it look like this? Right, like, what the fuck is going on here? I feel like seeing stripes like this is unexpected if we're lerping correctly. It does feel like the vertical lerp is okay, but horizontal seems backwards, to be honest. If that's true, because it is... Right side has a bigger number. Right side is bigger number. Left side is smaller number. So this should be like this. That is a good point. Computer? Good point. All right, this is the one. This is the one. Okay, that looks maybe more sane, but maybe we're back to our original problem now. I can't really tell. This is like kind of like tracing. Can we turn off this for a second? So our bus stops are here and here. And we are back to seeing like a hot spot here where there shouldn't be one. I think we've just reinvented our shitty behavior from yesterday, to be honest. I think we just reinvented the bad behavior. Again. Because we probably have just reintroduced this same lerp problem, right? Where we're not looking at our position relative to these. Right, so we missed the important part where here we need to we need to find like these are the positions relative to the corners, but we want the positions relative to us. So we want to do something that's like vec2 get offset, and we'll pass in an x and a y, and we will like basically do this. And our x and y, maybe we'll pass in our position in... Hold on. So we missed this part, frag offset. So this is our frag in minus sample pause. This, we need sample pause still. Sample pause. So this is a text val xy. Here we go. So we say text val is this. And the sample pause is text val xy, and the vec2 sample offs is text val.ba. So the closest stop is just at text val xy plus text val ba, which is a stupid format, I guess. Probably, that's fine. And then we want to basically sub that us from that. So closest stop minus our position. Yeah. And now we just pass in x and y here. Okay. So these are ints, I guess. So now we can still do this lerping, but we should call, instead of this, we should call get offs. So we'll do like something like jump to here, find some bracket, replace with get offs, jump to the other side of this, and then replace the semicolon. That's, I think, what I want. I don't fucking know what I want, what I really, really want. But maybe that's what I want, what I really, really want. This is still, I think, doing the same bullshit. Right, we have a bus route here and here, and it's fucking interpolating again. I feel like I'm missing a crucial... Oh, I mean, this is just the same fucking problem again. So maybe I want to interpolate their distances. Right, because both of these are going to have big distances. Right? Then here we get floats. Maybe? Right, so big distance and big distance interpolated always stay big distance, maybe, man. We're back to something else, but this something else is definitely the most sane thing we've had so far. I don't understand what it is we don't like. I don't really either, to be honest. There's a good chance this is correct, to be honest. Like, if I look down here and I see, like, every 2 blocks there's a bus stop, that's, like, maybe right. That could be. Like, I guess we could try, upping the sample size again here. Closest stop lookup. Let's, like, can we, like, up this to, like, 4? I think if we up this too much, it, like, fucking crashes our app. But maybe not in the web app version, only in the, like, native app version. Because I guess it does make sense that if we're trying to get to the closest stop, there are literal, like, legitimate stops that are the closest. And I don't really know how different this is than what we had at some point before. I don't fucking remember anything. But okay. Yeah, so this is kind of a problem here where there's actually a stop once per block. We're seeing like bigger hotspots with with higher sampling. So what I was hoping was that there was some mechanism that we could use to basically make it that instead of seeing like hot points, I wanted to see like a hot line. Where I kind of wanted to see some sort of like red glow tracing our bus routes. And maybe that's just not reasonable, a thing to get with this approach. I don't know. I don't know. And then also, I guess there's this question of like how much does it matter? Right? Like maybe we don't always have to get to the best bus stop. Right? Because like my problem here is if I go down to 25 by 25 now, like if I'm trying to like really, really like sparsely sample, like I don't really get something that I think is reasonable. Set path start, set path end. But maybe that's just like you can't sample this sparsely, right? Because like of course. Hmm. I wonder if there's some way to like represent this. No, I guess like if you're sampling this infrequently, it's just fucked no matter what. It is just fucked. We definitely have like a resolution that we would want to target. Even like 100 by 100 might not be good enough. Yeah. So my problem here is that like I really don't want this. Right? We saw for sure that there was like a bus stop once per block. Although, oh, that's an express bus. Right, like this bus stop. I'm so unsure about everything here. So unsure. So there's a bus stop there, there. No, that's a highway. Fuck. It's so hard to get it. I mean, clearly there should be a bus stop here. Why am I not selecting that node ever? What the fuck? Where's the bus? I'm so confused. Oh, here. This is where it's pointing to, maybe? This one? I don't know. I don't know. All right. Well, at the very least, we have something here. I don't think I like it. I don't think I like it. Aha, so when the sampling is sparser, so the box is bigger, we still want to highlight all red with the bus stops inside, not just one. That's kind of what I was initially thinking. But now that I'm like looking, like, there's something about like the, if here we think the bus stop is here, and here we think the bus stop is here, then like here we should think the bus stop is here. There's something about that like I haven't quite got right yet. And I think that's why I had like projections at some point as well. I guess like can I draw? I want to draw where the samples are. I think that'll help me gain intuition. I think that'll help you gain intuition. So here we have the positions somewhere. And it's like, if dist, but like if I'm like close enough to one of these, then I just color it in completely. I guess. I mean, we can. Sorry, I know that this is maybe not very riveting content when I'm just like him. Like, there's something about this that I don't like, right? It's that like here, I am saying that like. I'm trying to interpolate saying like, oh, here I think that this is the closest, and here I think this is the closest, and so I'm like kind of like evening out. But there's something about like, you know, if I'm looking like this, right? I definitely want to stay like big number. This is big, right? But if it's like this, and I've sampled here, then I want like this number. Which is why I was doing projections at some point before. And if they're like, yeah, that's why I was doing dot products. Is because my thought was that we don't know anything about like the things that we didn't sample in between. So I want to try going back to dot producting now that we have these bilinear interpolations working correctly. So instead of just doing closest stop here, I want to do like let me think. So we have position of the stop, we have position of us, and we have position of this to this. This is the sample, and we think we're like this far, much farther than that. So our sample offset is this offs. Then we want to call this like this vector additional is going to be like sample pause minus frag in, okay? Then we do additional offs dot this onto sample offs normalized. No. Onto sample offs. Maybe the normalized. One of these has to be normalized. Yeah, normalized. And then we add this. We like do. So that gives us this distance here. And we just want to add this to the total distance. Yeah. Closest stop is this. So we just want to add this to length sample offs plus this minus this. Minus this. Because if it's in the same direction, then we want to get smaller. I want to see what happens if we do that. I want to know. Fuck. Normalized. Because it's normalized, not with a D. I knew there was a reason for the dot product thing at the beginning. I knew it. But then I convinced myself I was wrong. As one does. As one does. 18, syntax error. Did I fuck up a semicolon here, maybe? What's the best way to learn? I mean, there's no best way. Oh, you said what for you is the best way to learn. For me, it's do. Right? The more I experiment with stuff, the better intuition I have about the stuff I'm working with, and the more that those like concepts can be applied to other things. There is a chance that this lines up more with what I wanted, except for the fact that it feels like the blobs are in the wrong spot. I feel like I might have got this dot product wrong. So here I have sample position minus frag in, right? So this is where I'm pointing towards the point that we are sampling from. Then this is the arrow from him to someone else. So this should be plus, I think, actually. If they line up, then they're in the same direction. All right, one more. One more try. I hope to God this is it, because I'm getting tired. Okay, so this right here, this was what I wanted. Now, whether or not this is good, completely different story. Completely different story. But this thing tracing this bus route is like, this is what I was hoping for. I would like to see how this looks if I increase the sample size. Oh, it's already pretty high. 200 by 200. Let's see what that looks like. It's very possible that this whole idea also just is bad. I forgot to refresh. If I want the new code, I should refresh. It's true. That is the way it works. All right, let's try again. This is definitely more what I was hoping for. This looks like pretty good, right? We now are not seeing any hotspots that aren't at the very least close to a bus route. Yeah, this is like this has gotten rid of yesterday's problem where we had like hotspots in between bus routes. Now, there's obviously like something wrong still, right? Like this feels kind of broken. Maybe it's like supposed to look like that. I don't know. But this is at least like the best answer we've got so far. The best answer we've got so far. And it's possible that some of these like missing spots are like actually places where there just aren't bus stops, to be honest. I don't know. Okay. I'm gonna call it here. I honestly think this is pretty good. Right? Like, oh, if I zoom out, this also like this looks really fucking good here. Right? Like, I have to go think about I have to go compare this with like real life bus stops. But this is a big improvement over what we had at the beginning of stream. So, worst case scenario, improvement. Whether or not it's good enough, who knows? But I'm gonna call it there because we're 45 minutes over what I usually do, and I've been streaming for like, close to like 4.5 hours now, so I'm getting a little tired. Thanks for watching, guys. I hope that this was entertaining to you. I know it was a lot of me just like crunching numbers, which is not ideal. It would be better if I was better, had a better understanding of exactly what I was doing. I could tell you, but not the end of the world. So thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:45 now, so a little later today, but that's okay. If you're new here, there's a YouTube link in the Twitch description where you can swing by and you can check out our projects. We're working on this map right now. There's a GitHub link in the Twitch description where you will see the code for this eventually end up under this FMAP repo. We have other projects too that we worked on in the past though, so you can check those out if you want to go back in time. That is available. What else? Like, subscribe, Twitch Prime, Patreon, blah, blah, blah. And, yeah. Okay, YouTube, goodbye. And Twitch, let's find someone to raid.